Okay, so today we're going to start section 2.6, absolute value functions and graphs. And just review quickly first of all, what is absolute value? Absolute value is the magnitude of a number. That is how far the number is from zero. Okay, so for example, absolute value of -5 is 5. The absolute value of 5 is also 5. Both are 5 spaces from 0 on the number line, so they both have absolute value of 5. Okay, and we are going to learn the general form of the absolute value function. And this is it. Y equals m times the absolute value of x minus h, and then plus k. We won't look at that a lot today, but we will go back at one of the examples. We'll see how this how this general form works. Okay, but just a quick look at it. M is the slope. Okay, and HK, the point HK, there it is the vertex. So the H comes from this number that's subtracted from x inside the absolute value bars, and the k is added outside the bars, and HK is the vertex of the graph. So let's take a look. We want to graph this one first. First example, graph the absolute value function. And here's the one we're going to graph, the very simple y equals the absolute value of x. Okay, so we'll graph it by plotting some points. And we will look at these points in particular. X values -2, -1, whoops, 0, and then 1 and 2, and we'll calculate what is the y value for each of those, and then we will plot those points. So when x is -2, what is y? Well, they're just plugging in -2 for x, right? And that is, so it's the absolute value of -2, right? When we plug in -2 for x, absolute value of -2 is just 2. Okay, if we plug in -1 for x, then that becomes the absolute value of -1, which is 1. Absolute value of 0 is 0. When we plug in 1 for x, we have, and I'll just go ahead and write one of these out. What we've been doing each time, we say y equals absolute value of x, and we plug in this case, 1 for x. Okay. Well, the absolute value of 1 is 1. Okay. So that's where we get the 1 that we're going to write right here. Okay, it's 1. I'll just take that off. Whoops. Okay, so when we plugged in 1, we get 1. We plug in 2 for x. Absolute value of that is 2. So there's our points we're going to plot. Let's plot them. -2, 2 is right there. -1, 1 is right there. 0, 0 is right there. 1, 1 is right there. And 2, 2 is right there. So there's the points, and we will just draw the line in, or the graph that is, and it looks like that. Okay? Make that a little bit better. Okay, so that's the first example. Let's look at another one. Graph the absolute value function, y equals, this time, negative of the absolute value of x. Okay, so we'll use the same values for x here. negative 2, negative 1, 0, 1, and 2. When we put in that negative 2 for x, we'll go ahead and show this one. We're putting in, there's the function, and all I'm doing is plugging in a negative 2 for x. Okay, so what is that? Well, the absolute value of negative 2 is 2. Okay, but we take the negative of that. So this is negative 2. Okay, we'll do one more, writing it out like that. Y equals negative of, that's just our absolute value function, right? And what we're plugging in for x this time is negative 1. So y equals the negative of, absolute value of negative 1, that's 1. Okay, so y is negative 1 when we plug in negative 1 for x. Okay, we put in 0, this is going to be 0. When we put in 1, we'll get 1 as the absolute value. We'll apply negative to it, negative 1, and 2, we'll get negative 2. Okay, so let's plot those. Negative 2 this time is negative 2. Negative 1 is negative 1. 0, 0, then 1. X is 1, y is negative 1. When x is 2, y is negative 2. So it looks like that. It's going to keep going in that direction. It's going to keep going in that direction. Okay. Let's look at the next one. Graph this absolute value function. The absolute value of x and then plus 3. Okay, we can use those same points. Now, this time, when we plug in negative 2 for x, the absolute value will be 2, but we're going to add 3 to it, so that's 5. When we plug in negative 1, absolute value of negative 1 is 1. We'll add 3 to that, and that's 4. When we put in 0, absolute value of that is just 0, but plus 3 is 3. And the absolute value of 1 is 1, plus 3 is 4. The absolute value of 2, when we put in for x, that absolute value is just 2, and plus 2 is 5. So we have these points. We will plot them. Negative 2, 5 is right here. Negative 1, 4 is right here. 0, 3 right there. 1, 4 is here. And 2, 5 is here. So we plotted the points. Looks like that. Okay. So let's look at the next one. Okay, the y equals the absolute value of x minus 1. Okay, so we'll use the same points again. Negative 2, negative 1, 0, 1, 2. And this time, inside the absolute value bars, we're subtracting 1. Okay, so let's do a couple of those. Write them out. We're plugging in a negative 2 for x here, and then subtracting 1. So that's what we get when we plug in negative 2. Negative 2 minus 1. Well, that's negative 3 inside there, right? We'll go ahead and write that. Absolute value of negative 3 is 3. Okay, so this is 3. Okay, we'll do one more. Plug in the negative 1. We'll write it out, I mean. Okay, so this time it's -1 in there for x minus 1. So y equals -1 minus 1, that's -2. Absolute value of that then is 2. Okay, so when we put in x, we get 2. When we put in 0, we're going to subtract 1 from it. So inside the bars will be -1. The absolute value of that is 1. When we put in 1, 1 minus 1 is 0 inside the bars. Absolute value of that is 0. When we put in 2 for x, we'll have 2 minus 1 in the bars, which is 1, and the absolute value of 1 is 1. So let's plot these points. -2, 3. And then we get -1, 2. And then we get 0, 1. And then we get 1, 0. So 1 on the x-axis and 0 on the y-axis does not go up or down. And then for x equals 2, we get 1. And that's going to be right there. So we have enough. It's not symmetrical. We don't have any more points out here, but we know where they will be. If we were to go to 3 for x, put in a 3. 3 minus 1 is 2. So the absolute value of 2 is 2. It would be right here, just as we suspect. I'll go ahead and write it in temporarily. Yeah, it's on the line. But we don't need that point, because we know once this turns like that, it's going to keep going. As long as we have enough to show where the vertex is, we're good. And the vertex is this point at the bottom, okay? Or if it's flipped over like the one was, we had one. The vertex of this one, it's not at the bottom, it's at the top, you might say. And but it's where the graph turns, you know, sharply. Okay. So we just have one more. And this one, we'll look at that HK thing for this one, the standard form, I mean. So let's go ahead and write that down again. Standard form is, we can refer back to it. There it is, y equals m times x minus h plus k. Okay. So let's write that down so we can kind of refer to it. Y equals m times x minus h plus k. And so the slope is m. Okay. And we're supposed to be able to get the vertex from this. And we take h as the x-coordinate and k as the y-coordinate of the vertex. So let's just cheat and use this to find our vertex before we ever graph the thing, okay? And so h is this number in here that's subtracted from x. Well, in our example, what is subtracted from x? You might say nothing's subtracted from x. 2 is added to x. But remember, we can rewrite that as a subtraction, right? If we wrote this as a subtraction, it would be, I'll write it over here, y equals x, and then we're going to say minus, and then that would be -2, right? And then plus 3. And all we did was rewrite that as a subtraction. But we have to do that because we need h, and this h that we're looking for is the number that's subtracted from x. And now we have a number, when we write it this way, we do have a number subtracted from x. It's negative 2. So what is h and k? Well, h we just found, that's negative 2. Now what's k? K is just the thing that's added after or outside the absolute value bars, and we can see that as when we rewrote it, it's 3, but we already knew that it's 3. So we have our vertex, negative 2, 3. So let's go ahead and just draw it in. Negative 2, 3. That's our vertex. And while we're thinking about this, we also have the slope. The slope is the thing that's multiplied on the outside. It's multiplied by the absolute value. Well, what is that in ours? What's out there that's multiplied? No, there's no number there, so that means it's 1, right? You could always write a 1 outside there. 1 is multiplied by the absolute value. So the slope is 1. So we could do a rise over run thing here. Rise of 1, run of 1, and put a point here, and we could then graph that without even plotting any points. Okay, well, let's see if that's the same thing. Let's go ahead and do it. Let's put it on dotted lines here. We think it's going to be like that, and then of course you have to do the negative of that slope to go the other way. All right, now that's not very good. Should be more like here. Let's see if it turns out to be that when we plot points. So we'll use the same ones we used before for x values, negative 2, negative 1, 0, 1, and 2. And we put in negative 2. For x, we have negative 2 plus 2. Well, that's 0. And the absolute value of 0 is 0, plus 3 is 3. So this is 3. And so we have, well, let's go ahead and plot the rest of the points. Negative 1, when we put that in there, negative 1 plus 2. That's 1. Absolute value of 1 is 1, plus 3 is 4. Put a 0 in there, then it's 0 plus 2. That's 2. The absolute value of 2 is 2, plus 3 is 5. Okay, and then we put a 1 in there. That's 1 plus 2 inside the bars, which is 3. Absolute value of 3 is 3, plus 3 is 6. And we put a 2 in there. We have 2 plus 2. That's 4. And then the absolute value of 4 is 4, and plus 3 is 7. Okay, so let's plot those. We have negative 2, 3. Negative 2, 3. That's the one we already plotted as the vertex. We use negative 1. Then we go 4. 1, 2, 3, 4. That's the one we already figured was on the line. Okay? Let's go to 0. And that's 5. And that's this one. And then 1 and 6. And that's about here. And then 2 and 7. So it looks like those are on the graph where of our dotted line that we already drew in. That's good. But notice none of those points we just plotted are on the left. We have one on the left that we did. Maybe I should have done those a different color. Oh well. That one right here, that's not from these points. That just came from using the slope being 1 that we use standard form, right? And we said, well, what's the slope that's out here outside the bars? It's just 1, and that's m, because m is the thing outside the bars right here. So if that's 1, I'll write that over here. Then we could use that, do rise over run, and say we have those 2 points. We have this point here, and then starting at the vertex, we did rise over run, but we used the negative of the slope to go the other way, the other part of the absolute value. So that's where this point came from. We need to plot another point though. So let's just use -3. Okay, and when we put in -3, and that's going to be this point, by the way, -3 plus 2, that's -1. Absolute value of -1 is 1, plus 3 is 4, and lo and behold, works out that when we have -3, 4, that is the point that we already figured should be there. So it worked. This is the same graph. I'll color it in now that we're sure. We used standard form to figure out what it's probably going to look like. We were right. We didn't make any mistakes. And when we plot points, we got the same thing. Okay, so that's our last example. We'll look at more of those tomorrow. So see you then.